Recently, Austin Whitsitt, who thinks that the Earth is a space pizza, interviewed Will Duffy of The Final Experiment, who's offering to pay for an all-expenses paid trip to Antarctica. And in this interview, Austin spoke about me. And he mentioned some things in a derogatory way about me, some accusations here. So let's have a listen to what he has to say.
They will claim that sunsets disprove flat Earth. To this day, we're talking about people that have been in the conversation for 8 years. Okay, sure. Let's just say, okay, you can disagree. I would reserve the dishonest accusation there. It's like, okay, still man of flat Earth sunset. They literally can't do it. They cannot do it. So if you've been in here for 8 years and you can't do that, you can't still man any of the flat Earth positions, but you know they're wrong. Like, you're dishonest.
Well, Austin, today is your lucky day. I will be steel manning sunsets on flat Earth just for you because you asked for it. I will do it. So steel man, if you don't know me, is the opposite of straw man. So straw man being creating a fake or an incorrect version of what the other person's position is in order to make it easier to discredit or disqualify. So steel man then would be having the most accurate representation of what the other position says. So that's what I'm about to do for flat Earth sunsets. So here is the map. That is the most common map. This is the Gleason's map. Flat earthers say, well, this is the new standard map of the world. And then they do like to mention that it's scientifically and something correct as it is. And they think that just because those words are on there, that it automatically is correct. Anyway, it's not. But let's go over this. I've got the sun analog here. I know it's not quite perfectly yellow, but we're going to treat it as if it's the sun. So what does the sun do? Well, here's what they think the sun does. They think the sun moves in circles over the Earth and it hovers over the Earth. And then to steel man the flat Earth position, what is the height of the sun over the flat Earth? Well, they don't know. They have no answer to that. So the height is unknown. You can try to measure the height by basic triangulation, things that you learn in middle school geometry, by solving triangles and, solving a triangle, but you can't. You get a different height for every location. So why is that? Well, magic is the reason why that happens, apparently. And then, anyway, okay. So now that we've determined why the sun hovers, unknown, or magic, now it goes in circles. And normally things that are not being have a force applied to them would go straight. They just keep going straight. This is elementary school science class. But for some reason, it goes in circles. Why does it do that? Unknown. So special pleading, or let's just call it magic. So magic makes it go in circles. Now, some flat earthers think that the sun, not all of them, goes up at some parts of the year and then down at other parts of the year. What causes the sun to move up and down? Magic. Okay. Then the sun outputs heat and light to different portions of the Earth. And so then what, of course, is what's the source of the heat and light? What causes the flat Earth sun to output heat and light? It's not big enough to have nuclear fusion, and and of course they say gravity doesn't exist. So what is the cause of that? They don't know. Magic. So then throughout the day, the angular width of the sun doesn't change much. It remains very, very constant. So for example, if somebody's here in Mexico, say, when the sun is over them in Mexico, it's the same size as when it's over here. Several hours later, are very consistently the same size. Why is that? Magic. And then they say, well, what causes it to set? Well, when it gets so far away from you, it will set. Well, how far away does it need to get in order to set? Well, that's unknown. They don't know that. So it doesn't. In fact, it's even worse than that, because let's say you've got a, right here. You've got this line right here, and on the equinox, which is mid-September. Let's say on the equinox the sun is here, and it's about 6 hours from here, right? So here is midday, and now 6 hours later the sun is about there, right? We'll put it about there, and it's sunset time. So everybody along this line experiences sunset at the same time on the equinox. Well, of course, the equinox is when the sun is over the equator. So it's about there, right? So now you've got the sun. This is the steel man. So for the people, it's too far away. So the people that are here, let's go Canada here, right? They have this distance right here to the sun from their position here in Canada. That's how far away it needs to be to set for these people. But for these people here in Quito, Ecuador, they need to be this far away. I'll go from here. Here we go. It doesn't matter. Everybody along this line experiences sunset at almost exactly the same time. So the people in the very southern tip of South America need to be how far away? Well, this far away, in order to be far enough away for the sun to set. How far is that? Well, they don't know. That's an absolute mystery. So, but I'm steel manning that, again, they don't know. So now we've got the sun here, and now what time will it set according to the geometry and optics and physics of this map? They don't know. They have no idea what time it will set. In fact, if you go to dateandtime.com, they use they use the globe to predict the date, this time, and of course they're correct. Now, some flat earthers will say, like Witzich says, that the light, it gets tired. It's tired light. And so, of course, the light traveling this path gets tired faster than the light traveling this path, right? It can go farther. Why? Well, somehow the light leaving the sun here knows that it's going to go here and that it needs to go farther. So it boosts itself a bit more, maybe. Sometimes Austin will say light extinction. That's another thing that, of course, I don't know but anyway, they also say perspective. But of course, perspective, if you apply perspective, then of course, this is an upward angle, right? So that doesn't work very well. That this perspective says that, here's the triangle, that the sun would have to be visible, or that the sun would have to be above the horizon. So steel manning flat earth sunsets, it needs to be higher. So anyway, but it's not. And why is it setting when it's not actually matching geometry? Magic. So, okay, what time will it set? Don't know. What time will it rise? Don't know. And what about the angle to the sunrise and sunset? Of course, that's a bit of a problem, because on the equinox, everybody on this line will see sunset at the same time. And not only that, they will all see the sun set almost completely due east. And then here they're going to look at the sun setting due east. And then here they're going to see the sun setting due east. So remember, this is the straw man or the steel man of the sunset. So the flat earthers say that the sun is actually here, but in reality, when you're here and you look that direction, you see it. So it's not actually even this line that the light has to take. Somehow the light has to take this line to get to the observer there, which is a lot longer than this line because it's not a straight line. And also to get here, it has to have a similarly curved line to get there. Why does it do that? Again, magic. So when you apply geometry, optics, and physics to the angle, the time, the elevation, basically everything, why does the sun set when you apply geometry, math, physics, optics, and you apply all of those things to the sunset, why does it not match those things? Well, the answer, of course, is magic. That's why the sun sets on flat Earth. That is the steel man of flat Earth sunsets. It's all magic.